Okay, so a completely brand new topic today. You'll be pleased that we've finished all that surface area business. Can I just say, I thought some of you did an extremely good job on that surface area of a cylinder. Lots of you were giving a really good crack to those first 6 questions. They were the ones I told you to focus on. And Fliss, that effort to do all 10 was a great effort. I think it was only one you got wrong, wasn't it, or something? That was a really, really good effort, so well done. Anyway, brand new topic, okay? Plans and elevations. And this is going to lead us into trying to do Hegarty 837, please. So what are plans and elevations? So what we're doing here, you've got to imagine that you've got some three-dimensional shapes and that you're an architect and then you're just drawing some plans. So you could be drawing some plans on paper looking as a bird's eye view, looking from above, looking down. That's typically what architects' plans do. They sort of look downwards. But then equally, you could be drawing some plans from the side of a building. So you could be doing some plans looking from the front of the building or from the side of the building, for example. Okay, now getting used to the definitions, the plan view, that is the one that is the bird's eye view. That's the one when you look from above. And the way they go and tell you in questions where you're looking from, they will go and put an arrow on it like that. So if you've got an arrow above it, they are you are looking down from an aeroplane above, okay? And it's what view do you see? If you were looking down at this cube from above, you've got no idea how deep it is or anything. All you would do is you would see a square, okay? Now, the side elevation is pretty much what it says on the tin. That's just if you were looking at a building from the side. So over here is an example of us looking from the right-hand side. And again, in this simple example where we've got a cuboid, you're just going to see a square. You've got no idea how wide the building is when you're looking from the side. You imagine you're in the front, you've got a house in front of you. You can see the front of it, but you've got no way of knowing how far back it goes. It could go back for miles for all you know. Okay, and the front elevation, so side elevation is when you're looking from the side, front elevation is when you're looking from the front. And again, you're looking at a house from the front, you've got no idea how deep it goes because all you can see is the front, the square. So what we use to represent the three-dimensional buildings as a starting point, they get drawn on what's called this isometric paper. Okay, so we're just going to assume that that each of these squares on this isometric paper is 1 centimeter. So it takes a bit of getting used to. Some of you might find this easier than others. You've got to appreciate that dimension there, if you're looking from the front, that is 1, 2, 3, 4 squares wide. The height one's quite easy to see. That's just a height of 1, 2, 3, 4. And the width going backwards, so that the depth of that cube, again, you're doing that on the angle, aren't you? So that's 1, 2, 3, 4. So it's really important that looking at that isometric paper on the left, that you would be able to label that up and see, right, I can see that looking from the front, my base is 4, the height is 4, and the depth of it is 4. Okay, now when you draw your plan view, so remember the plan is looking from above. So when you look down from above, you're just going to see this surface here, aren't you? And that's just 4 by 4. So there's your plan view. When you look from the front, okay, when you look from the front, then obviously you're just seeing the front of the building. You're seeing that face there. And with this easy example, that's just a 4 by 4. And obviously, when you're looking from the side, you get the side elevation. Again, with this simple example, you can see that base is 4, the height is 4, so it would just be a simple 4 by 4. It doesn't matter where you draw it on the paper, okay? It just needs to have a base of 4 and a height of 4. So let's look at some more complicated examples. Okay, so here we go. So obviously we've got a cuboid here. So when we're looking from the front, well, first thing, of course, you would have to go and appreciate that that's got a base of 4, a height of 4, and a depth of 6. So just be careful that you can just see that's 1, 2, 3, 4, 5, 6. So first things first, just get your dimensions sorted out. Then remember, the plan is your view from above. That's your bird's eye view. and we can see that that's got a width of 4 and a base width 4 by 6. It doesn't actually matter which way around you did this 4 by 6. If you did it the other way around and did it 6 by 4, you would still get the marks. But you just need to appreciate that if you're flying over that building from above, looking down, it sort of gets flattened into the ground. You can just see that the roof area is a 4 by 6. Now the front elevation, okay, that's just the view from the front. That's a 4 by 4. And our side elevation, obviously looking from the side, that's obviously 6 along the bottom, 4 up, so that's our 6 by 4. Okay, so, right, again, I wouldn't say more complicated, but we just need to be a bit careful here, okay? A bit careful with a couple of these. So I think the, let's get the easy one done first of all. I think it's easy that you can see looking from the side, you've got a base of 4 and a height of 4. You then join the diagonal. So that's a pretty straightforward one. Okay. Now, when we're flying over this above, okay, you've got to imagine it being flattened down onto the surface again. Okay. So what would we see from above? We would see that it's 6 wide. Okay. So that's easy enough. There's our 6. But we're going to see that it's really going to get flattened down. So don't get fooled and think you've got to count that length there. That would be the, as you look from above, that would be the height that you see. That would be this dimension here. Okay. If you're sort of looking down from above, you're going to see a 6 by 4. So just be careful that if you're just flying over, you would actually see a rectangle with sides 4 and 6. Now, the side elevation, we also need to be careful. You're looking from over here. I think it's fair enough that you can say that the width would be 6. That's easy to see. But can you see that really it would flatten backwards? You wouldn't appreciate that it's sort of angular here. All you would see would be this height of 4. Okay, looking from here, you're going to be looking onwards, and that's going to be the view that you're going to see. You've got a base of 6, but a height of 4. Right, okay, couple more examples. So, now, if you were flying over this one here, okay, I think we're okay that we would say that we've got a 4 by 6, okay, a 4 by 6. So 4 by 6, but you effectively would be seeing that it's all flattened down from above. Because you imagine you're flying over this and you're looking down. That's what the roof would look like. So you would see this line here. You would see this line. So that line needs to be included in the middle, because you can see as you come down, that's exactly in the middle of the 4. So where you've got what's called a this line here, where you've got this line here, okay, then that line does need to be represented in the plan view. I think the other two are pretty self-explanatory. Obviously, if you're looking from here, but remember that's telling you what the front is. Remember the arrow tells you what the front is. Looking from the front here, we would obviously see this triangle. So that's easy. And looking over from the side over here, this view here, you'd have a base of 6, and just be careful you're happy that actually it would all flatten downwards. You would see it flatten backwards, I should say. You would see a height of 4. So just make sure you can see that if you're looking sideways, base of 6, but a height of 4. Do not try and start thinking this would be the height you see. You don't. This would all flatten backwards, giving you that height there. And the final one, I just wanted to show you, very similar to the one we just did, but notice how this top of the roof, if you like, is not right in the middle of the triangle. It is 3 squares along. It's 3 squares along. So as you draw this 4 by 6 rectangle, just make sure that that extra line you need to put on the plan doesn't go in the middle, because that beam of the roof, if you like, is not in the middle. It's 3 squares along. The other two, I think, are pretty self-explanatory. Okay, your front elevation, and it's called the front because this is the front because of the arrow. And then your side elevation, when you were looking from over here, you'd have a base of 6 and a height of 4. Now, it may well be, because Mr. Hegarty's done, I've just pinched these slides from Mr. Hegarty. If you're still a bit unclear, I would suggest you go and watch Mr. Hegarty's video before you start the exercise. If you feel completely on top of it, please just go and make a start now on Hegarty 837. As always, I will upload this recording onto YouTube in a minute. It automatically uploads onto Teams, as you know, and I'll be monitoring the posts on Teams if you've got any queries over the next hour. And obviously, I'll be keeping an eye on your marks, transferring them over onto Teams and giving you sort of feedback straight away. Well, thanks very much, so many of you turning up for the live lesson. All right, and good luck with the exercise.